Okay, starting with number 5 in our factoring polynomial section. So we are still doing our bottoms up, and I'm going to take the first and multiply it to the last. So 1 times 7 is 7. So I'm going to find the factors of 7 that add to give me a positive 19. So I want to add to get a positive 19. The only factor of 7 is 7 and 1. And I'm going to add and I'm going to get an 8. And that doesn't work. Since I have no more factors to choose from, and I'm never going to add factors of 7 to get a positive 19, this is what we consider a prime polynomial. And it is only prime when you cannot have any factors to add or subtract to get that middle term. Okay, so this will be your answer, and that's as far as we can go on that example. Now let's go to our next example. I'm sure y'all are excited about that one. All right, the next example, I have 5x squared minus 70x plus 30. 5, and then this one ends in a 0, and this one ends in a 0. So that means that I know 5 will go into anything that ends in a 5 and 0. I have a GCF in this problem also. So if I have a GCF of 5, I'm going to take out a 5, and 5 will go into 5 one time. I'm left with the x squared. 5 will go into 70. Well, 5 will go into 7 one time, and 5 will go into 20 4 times. And I'll show you what I just did. I just divided 5 into 70. 5 will go into 7 one time, and 5 will go into 20 4 times. So that's how I got the 14. I was just dividing pretty quickly, and I don't know why I wrote my little parentheses there. And then one more, 5 will go into 30 6 times. Okay? Now, before I go any further, if some of you did not see that this was a GCF, a good reminder to check your GCF is when I multiplied the 5 and the 30, and I would get 150. This is kind of a big number. Sometimes you do have big numbers, but most of the time, if you have a big number, the first thing I would check would be to see if there's a GCF, just to make your numbers smaller. So if you do ever do your bottoms up and you get a number that's above 100, try to see if there's a GCF that you can take out to make your numbers smaller. And since there was a GCF for this one, that's going to be something that's going to help you. So I'm going to go ahead and continue with our bottoms up. And remember how I wrote down the first one last time and I wrote the rest in bottoms up form after I finished? And I scratched this out. And I said, all right, we're going to do our bottoms up and multiply the first and the last. So I want to find the factors of 1 times 6 is 6 that add to give me a negative 14. So if I'm adding to get a negative 14, let's think of our factors of 6. We have 1 and 6, 2 and 3. Well, if I add 1 and 6, I get 7. 2 and 3 is going to give you 5. Neither of those are going to give me a negative 14. Now, I want to remind you of our last example that we just had. So that example, it was prime because I couldn't find any factors of 7 that add to give me 19. And this one, I was able to take out a GCF, but I haven't been able to find any extra. I couldn't do the bottoms up with the trinomial that was in the parentheses left. That does not mean that this is a prime polynomial. What I'm going to actually have to do is rewrite that trinomial that I kind of scratched all over, and this is your answer in factored form. Just because I couldn't do bottoms up does not mean it's not prime. Look at our example in number 5 and look at our example in number 6. Whatever we had in number 5, that's as far as we could go. We could not do a GCF in number 5, so we didn't change it from its original form. That's what made that polynomial prime. In number 6, we changed it from its original form and we were able to take out a GCF. So since we could take out the GCF, that means that it's not a prime polynomial, and that's as far as we could go. We couldn't go any further with our trinomial, but that's all right. We still factored it in a way, And so that's why we're not going to go any further with number 6. It's not prime, but that's the answer in factored form. Okay? Let's stop the video here. We're going to pick up with the next couple in the next video.